Okay. So Manohar, you want mock for thermodynamics, snap mock for thermodynamics.
Yes, sir. Yes,
So you are preparing for ISRO.
yes, sir.
Manohar, when is your interview?
Sir, my interview scheduled on 13 July.
13 July. Okay. So what do you like in thermodynamics?
Sir, in thermodynamics, sir, basic thermodynamics.
Hmm.
Yes.
What do you mean by law of conservation of energy?
Sir, law of conservation of energy tells us that energy cannot be created nor be destroyed. It can be converted one form to another form.
Hmm.
Yes, sir.
Okay. So if you will take a example of a steam power plant,
Yes, sir.
how energy conversion is taking place?
Sir, in steam power plant, sir, we uh, give the energy with the help of fuel to the water, and the water boiling and the and the generate the steam, and that steam
Mhm.
we derive the turbine, and with the help of that we got the work, and all the amount of heat which is supplied by the fuel is not used to work transfer. Some of that is rejected in the form of heat through the condenser, and some of heat is also lost during the transfer from fuel to the water due to different type of heat transfer.
Acha, if you will talk about this Rankine cycle, okay. So
Yes, sir.
where are the irreversibilities? Like where you feel irreversibilities are higher? Whether it is the higher irreversibilities are more in boiler, turbine, condenser, or pump. Like these are the four major components of Rankine cycle, right? Or
Yes, sir. Yes,
in which the irreversibilities are more?
sir. I think, sir, irreversibilities are more in the boiler, sir, where heat transfer is taking place at the.
Mhm.
Yes, sir. Sorry, sir. Sir, in that case, the generation of heat at the another temperature, and the heat taken by the water is different temperature, so that, sir, there is a finite temperature difference. Due to that, there is irreversibility generated.
अच्छा कहाँ पे है boiler में what type of irreversibilities are there?
Sir, due to the heat transfer through heat generation and to the water, sir, there is a finite temperature difference like this.
Okay.
Yes,
Mhm.
sir. Due to that, external irreversibilities are produced.
Fine. So what do we do actually? What do we do in actual Rankine cycle to decrease that irreversibilities in the boiler section?
Sir, we assume that there is no external irreversibility. We assume that the heat transfer is takes place at the same temperature, or
No,
we can
that we assume in Carnot cycle only, Manohar. In Rankine cycle, we are not assuming the heat transfer is taking place at same temperature. Rather, the heat addition process is at constant pressure.
yes, sir. Sir, in the Rankine cycle also there is a pump where also due to the friction, irreversibilities are produced, and we
So
assume that
I'm just asking you, Manohar. Try to just think what we do actually in the boiler section to decrease the irreversibilities.
in the boiler. Sorry, sir.
You heard about economizer?
Yes, sir.
क्या करता है economizer?
Sir, economize generally preheat the air which we supplied, sir.
Preheat the air or
Yes,
preheat
sir.
the water?
Sorry, sir. I am confused. Yes, sir. It is used for preheat of water, because for air, sir, there is a air preheater used.
Hmm. So for heat by heating the water, what we are doing?
Sir, by heating the water, sir, uh, we increase the temperature of that feeding water, so that heat
So can
transfer
we say
takes place.
can we say we are decreasing the temperature difference between the flue gases and the water by preheating
Yes,
it?
sir. Yes, sir. Yes, sir.
So what we are doing? We are decreasing the external reversibility.
Yes, sir. We are decreasing the external reversibility by increasing the temperature of the water, sir, so that heat addition is take place at the higher temperature.
Yes, so that's why we will
Yes.
have more efficiency by using the
Yes, sir.
economizer. The irreversibility will be decreased, and we will have more efficiency. So
Okay,
economizer
sir.
is actually used to decrease the irreversibilities at low temperature in the boiler section. What we do
Yes,
to decrease the irreversibility at high temperature in the boiler section, Manohar?
sir. At the high temperature side, we use the superheater.
Mm-hmm. Superheater.
Uh, yes, sir.
So superheater से भी same advantage मिलेगा.
Yes, sir. Superheater से sir हम लोग we feed the heat at the higher temperature.
Hmm. अच्छा Manohar, can you tell me the difference between first law efficiency and second law efficiency?
Yes, sir. Sir, first law of efficiency is sir work produced by the system. We measure the work produced by the system with the of the heat transfer, sir. And second law of efficiency, sir, tells us what is the work produced with respect to the work potential, maximum work potential of that system. What actual work is produced with respect to that of the maximum work potential. So that's basically with the help of only first law of efficiency, we cannot tell the performance of any system. Like sir, if there is two heat engine, one heat engine is operating between the 600 and 300 temperature source and sink, and another engine is operating between the 1000 degrees Celsius and 300 degrees Celsius. So if both the engines are having the same first law efficiency, let we assume that 30 degrees Celsius, both the engines are having the same first law of efficiency, sir. If first engine is operating between 600 and 300 degrees Celsius, and second engine is operating between 1000 degrees Celsius and 300 degrees Celsius, and the same amount of heat we can extract from both the source, that is, let's suppose 300 kilojoule.
What
If
do you
sir
mean by
both are,
exergy destruction?
yes
No.
sir, yes sir,
What is exergy destruction?
sir, exergy distraction is sir
ये से बोलते हैं
the law.
exergy lost.
Yes sir,
Exergy lost.
yes. Yes, sir. It is, sir, also known as irreversibility. It is the loss of, sir, maximum work potential of any heat engine.
So how we can measure that? Like suppose if you
Sir,
want to measure the exergy destruction or exergy lost, how we can measure?
sir, we measure, sir, with the help of one mathematical formula, that is, let's suppose the dead state is our surrounding. So, uh, surrounding temperature into the entropy change of the universe, or we can say entropy generation. With the help of that, we can find the irreversibility.
I suppose Manohar, if I will give you some spherical ball,
Yes,
okay,
sir.
of some mass, suppose 5 kg, okay, but it's a steel ball having some specific heat, okay,
Yes,
and
sir.
it is at some temperature 600 Kelvin.
Yes, sir.
If you will drop this ball into some water tank
Yes, sir.
at temperature 300 Kelvin,
Yes, sir. Sorry.
okay, and in this process, Manoj, suppose we are interested to calculate the entropy generation. So how you will calculate? Just tell me the process.
Okay, sir. First, sir, we find the equilibrium temperature of that solid body. So the sir, that equilibrium temperature is the temperature of the surroundings, sir, because it is a reservoir, so that temperature change of that water is not that much. So we assume that final temperature of that body is equal to the temperature of water. With the help of that, sir, we find what is the total amount of heat that is to be supplied by the ball to the water, sir. And there is this ball is a finite heat capacity body, sir. So for that, that is our system. So for that, sir, there is MC into ln T final upon T initial. With the help of that, we find the entropy change of the system. And sir, as well as there is entropy increase of the surroundings, sir, and that is a reservoir. That is a reservoir.
So this
So for the
water tank, you are considering it as a reservoir.
yes, sir, compared to the still body, not changing the temperature too much, sir, for the water. if
Mhm.
if sir we consider it as a finite body also that
Mhm.
water, then same formula will apply for the water also, sir, and we find the final temperature with the help of heat balance, energy balance.
Mhm. How you will
Yes,
write the heat balance? What is a finite temperature body?
yes, sir. Finite temperature body is the, sir, body which is having some specific heat.
Mhm.
If we,
कैसे निकालोगे? How you will find out the final temperature?
sir, whatever heat supplied, that is to be absorbed by the water, sir. So initially, sir, MC T initial for the this body, and minus we don't know the, sir, final. So plus that energy is absorbed by this water, sir. So we equate the heat that will be supplied, so that M of water into C of water into the T initial minus T final of water, sir. With the help of this equation, we find the final temperature, sir, only that is unknown.
Okay. Okay, Manor, I'm giving you 4 minutes. Okay. Just tell
Yes,
me what actually you learned from the thermodynamics. What information we are getting from thermodynamics
yes, sir.
application point of view, and how, where actually this subject helps us.
Yes, sir. Uh, sir, in the thermodynamics, sir, we first, sir, know how we convert the non-organized form of energy that is into heat into the organized form of work, especially in the case of, sir, or automobile industry, where we use the bike, car, where we generally there is a non-organized form in the form of fuel, which is having the non-organized form, and we convert it into the organized form of work to move the vehicle. And also, sir, with the help of second law of thermodynamics, before going to any expensive project, we can find whether this project is actually possible or not with the help of that second law of thermodynamics. If the entropy generation is, we can say, negative, then that project may not possible, sir. If greater than zero, then only that project is possible. So we can proceed further, sir. So and sir,
What is the application of thermodynamics?
sir, application of thermodynamics, sir, in the field of power plant, where we use the uh, finding the work done, uh, and also, sir, in PV diagram and TS diagram. With the help of that, we can find what is the net work output by any cyclic device, and with the help of TS diagram, we can find heat transfer during the process. If it is cycle, then it gives the total heat transfer,
Mhm.
net heat transfer.
Achha, Manor, my last question is to you. You heard about Carnot theorem, Clausius theorem. आपने
Yes,
सुना है? Clausius. Just tell me both. Clausius theorem and Carnot theorem.
yes, sir. Carnot theorem says that, sir, if we put the number of heat engine, we put the same temperature limit. That is the given constant temperature source and the given constant temperature sink. Then none has the efficiency higher than that of the reversible engine. Reversible engine is that is Sir Carnot theorem. And according to Sir Clausius theorem, the cyclic integral of the dq by t for the reversible process is equal to 0.
Acha, this
It's a
time
reversible cycle.
reversible cycle. Acha, if you will ask you to derive this cyclic integration of dq by t equal to 0 for a reversible cycle,
Yes, sir. Yes.
can you prove that?
Yes, sir.
Mm-hmm.
Sir, we know that any process we can replace between the two processes. That is two reversible adiabatic and one isothermal process.
Mm-hmm.
So, sir.
Yes, go ahead. I'm getting it.
Yes, sir. Sir, in that case, any cycle we can reduce in the small cycle and replacing the.
Any process, not cycle.
Yes,
Any
sir.
process.
Yes, sir. Yes, sir. By so we replace the sir in the isothermal and
There's a
two reversible adiabatic.
reversible cycle. You are drawing a reversible cycle.
Yes, sir. Yes, sir. That is reversible cycle. For that, sir, if we make small cycle, reduce the small cycle, the large cycle, then sir, whatever heat input for a small element, that is, let's suppose the TQ1 for first cycle, and the heat rejected from that is TQ2, and that is happening, sir, at the constant temperature. And with the help of sir Clausius sir, absolute temperature thermodynamics temperature scale, we know that TQ1, the ratio of the heat interaction between the source and the sink is equal to the corresponding temperature, ratio of the corresponding temperature. With the help of that, we can dq1 upon dq2 is equal to t1 upon t2.
You know what this thermodynamic temperature scale Manoj? पता है आपको?
Yes,
What is
yes,
that?
sir. Yes, sir.
Okay, Manoj, let me give you the feedback. ठीक है.
Yes, yes.
You are going on the right direction, Manoj.
Yes.
So let me give you the feedback. Manoj,
Yes.
theoretical point of view, your knowledge wise is fine, like you know the things. Okay, but
Yes.
again, my suggestion is to you need to represent yourself in more effective manner. अभी थोड़ा सा मेरे को वो एनर्जी वो कॉन्फिडेंस नहीं लग रहा है, ठीक है?
Yes.
That you need to work. Your knowledge is fine, Manohar, और अभी आपका बहुत कुछ इम्प्रूवमेंट है. लाइक मेरे याद है कि जब हम लास्ट इंटरेक्ट किए थे, I think more than 2-3 months ago.
Yes, sir. Yes.
So your delivery is improved. Okay, your maturity is
Yes,
also
sir.
reflecting. This time you are looking
Yes.
more confident also. But
Yes,
again,
sir.
you need to make it more effective. वो कैसे करना है?
Okay.
तो थोड़ा सा प्रैक्टिस करो, ठीक है? थोड़ा
Yes,
सा
sir.
टाइम लेके आपको कन्विंस करना है. देखो अभी आप क्या कर रहे हो, जस्ट आंसर कर रहे हो. There is a very minor difference between just answering and explaining.
Yes, sir.
आपको मेरे को explain करना है, मेरे को convince करना है. Like a teacher, when you are having the opportunity to convince something, to make someone understand that particular point, so you need to put everything in that. Manor,
yes, sir. Yes.
वो काम करना है. अभी मेरे को वो थोड़ा सा मिसिंग लग रहा है. Are you getting my point?
Yes.
You are sitting in front of me, you are answering, that is fine, but it is like a just viva जैसे स्कूल का कॉलेज का viva होता है ना, कि I am asking you and you are answering. उसको एक्सप्लेनेशन पे लेके जाओ, नेक्स्ट लेवल पे लेके जाओ. एक्सप्लेनेशन मतलब जैसे टीचर एक्सप्लेन करता है ना, सब कुछ उसमें डाल दे, कोशिश करता है, हर बंदा कोशिश करता है, तो यू आल्सो यू नीड टू ट्राई इन दैट सेम वे. ठीक है, दैट इज ओनली पार्ट व्हिच इज मिसिंग. अदरवाइज योर नॉलेज इज फाइन. मोस्ट ऑफ द क्वेश्चंस यू आंसर्ड, लाइक द बोल क्वेश्चंस आई आस्क्ड यू दिस. शुरू में वो आप मिस कर गए थे, रैंकाइन साइकिल में रिवर्सिबिलिटीज, वो याद रखो ना. अब वो भूलने की चीज है, इकोनोमाइजर, सुपरहीटर, बट व्हाई वी अटैच टू increase the mean temperature of addition, we attach to decrease the external irreversibilities. तो उसको भूलना नहीं है. देखो एप्लीकेशन पार्ट नहीं, because the ISRO interview they will club these all subjects ना. You will not able to mention कि sir I have prepared thermodynamics, because why I asked you, I started with that question because already I think you appeared in so many thermodynamics snap offs. Okay.
Yes, yes.
That's why I asked you this particular question. तो थोड़ा सा चीजों को recall करना है और उनको answer करना है. I think all things will be fine, and you will be able to present yourself in an effective manner, and surely you will be able to succeed in this particular direction. Your interest. So from my side, best of luck and keep preparing, Manohar. Anything you want to ask, so you can ask. So good luck, Manohar, and keep preparing.
Yes, sir. Yes, sir. Thank you.